In section 1.2, we are going to be talking about quadratic equations, and we are going to review 4 methods to solve. The first method we're going to talk about is factoring. So, in order to be able to solve by factoring, you have to know that it only is going to work if you can factor the quadratic. If the quadratic equation cannot be factored, then you're not going to be able to solve it. But if you can factor it, then this is a really fast method to solve them. Here are the steps. Step 1, you're going to want to get your equation to say equals 0. So that means we need to move some stuff around in order to get it to say equals 0. Now, I will tell you that when you're factoring, you're going to want your leading coefficient to be positive. So rather than move this 2x squared over to the right, which would be the fastest thing, I'm going to move the 19x and the 33 over to the left. That way, I have 2x squared and then minus 19x minus 33 equals 0. So that's step 1. Step 2 is factoring. Now, factoring, I'm going to review that with you, the AC method for factoring. The first thing that you're going to want to do is look for a greatest common factor. So we would look to see if any of these terms had a GCF, which it doesn't. So then I move on to the AC method. In the AC method, we're going to take A, which is going to be our first term, times C, which is going to be our third term. So we're going to multiply those two together. 2x squared times negative 33 is negative 66x squared. And I'm going to start listing out things that would multiply to give me negative 66x squared. And I'm going to look for the combination that's going to add up to give me negative 19x. So like I could start with 2x and 33x, or 3x and 22x, or let's see, 4 won't work, 6x and 11x, or x and 66x. Okay. Now, when this is a negative number, I know that one has to be positive and one has to be negative. So I'm looking for the combination that will give me negative 19, and that's going to work here if I use 3x as positive and 22x as negative. So then the next thing I do is I'm going to rewrite this problem, but I'm going to make the negative 19x, replace it with 3x minus 22x. So basically, I'm going to have 2x squared and then plus 3x minus 22x minus 33 equals 0. So I haven't changed the problem. I've just rewritten that 19. Then the next thing that I will do is I will use factor by grouping with these 4 terms. So I'm going to group my first 2 terms together and my second 2 terms together. And I'm going to take out a GCF from each group. So out of this group, looks like all I can take out is an x. So I will put an x out front. And then 2x squared divided by x leaves me 2x. 3x divided by x leaves me plus 3. And then I know I've got to take out the same thing to make 2x plus 3 here. Another thing I got to keep in mind is if my group starts with a negative, I have to factor out something that's negative. So I'm going to factor out negative 11. So like that. And then I still have equal 0. And then the last piece of my factoring part is that I'm going to take This group that's in common, 2x plus 3, that's going to make one of my parentheses. So I'll have 2x plus 3 in one parenthesis. And then I take these GCFs that are out in front. That's my other parenthesis, x minus 11. And I still have equals 0. So that's the factoring part. Then the next thing is to use the zero product property. Zero product property says that if I have two things that multiply to equal 0, I set each part that contains a variable equal to 0. So zero product property, set each part that contains a variable equal to 0. So I'll set 2x plus 3 equals 0, x minus 11 equals 0, and then solve those like I normally would. So I get 2x equals negative 3, x equals 11, divide by 2, divide by 2. So x is negative 3 halves, or 11. So as a solution set, I would get negative 3 halves and 11 for my two answers. So let's look at an example that looks slightly different. This guy here has a parenthesis in it already. In order for us to solve by factoring, your equation has to say equals 0, and it can't already have any parentheses in it. So I would have to start this one out by distributing that 6x into both of those terms. So that will give me 6x squared minus 6x equals 21 minus x. Then back to that first step, we have to get equal to 0. So I need to add the x over here and subtract the 21. So now I have 6x squared minus 5x minus 21 equals 0. Okay, now we are set to start factoring. So remember, we're going to take the first thing times the third thing. So we're going to be taking the 6x squared times the negative 21. 6x squared times negative 21 is negative 126x squared. And I need the combination that adds to give me negative 5x. So let's see. Got 3x and 42x. 6x and 21x. 9x and 14x. Ooh, there we go. 9x and 14x. So since I need it to be negative 5, it'll be plus 9x minus 14x. So I'm going to rewrite this problem. 6x squared plus 9x minus 14x minus 21 equals 0. And then I'm set to start grouping. Remember, I'm going to group the first two pieces together and the second two pieces together. So grouping here, grouping here. Out of that first group, I can factor out a 3x. In the second group, I know I'm going to have to factor out something negative because it started negative. So let's just go with 3x here. That'll leave me 2x plus 3. And then I know this has to still match 2x plus 3, otherwise I can't factor it. So I'm going to have to divide out a negative 7. So 3x minus 7. So we got that going for us. Then we are going to pull out the GCF from each into one parenthesis and the common parenthesis into the other parenthesis. So one parenthesis is going to be this common parenthesis of 2x plus 3. The other parenthesis is going to be the GCFs of 3x minus 7, still equaling 0. And then we move on to the zero product property. So we set each of these equal to 0 and then solve. So we got 2x plus 3 equals 0, 3x minus 7 equals 0. So I would subtract 3 from both sides. So 2x equals negative 3. Divide by 2 on both sides. So x equals negative 3 halves. Add 7 to both sides. So 3x equals 7. Divide by 3. So x is 7 thirds. So we've got two solutions again. Negative 3 halves for one of them and 7 thirds for the other. Let's see what's on the next page. Oh, another example. Two more examples. Hey, pay no attention to this little black box there. That's an oops, but I couldn't erase it because it's pen. So again, we're going to solve by factoring. Solve by factoring. So this one here, we got to start out by making it equal 0 because that's the first step in solving by factoring. So I will subtract 7x over here from both sides. So I get x squared minus 7x equals 0. The next step is to factor it. And remember, the first thing I do is look for a GCF. I forgot to mention that on the second problem because it didn't have one, but this one does. Both of these terms have an x in common. So I'll factor out an x, and I'll have x times x minus 7 still equals 0. Now when I look inside this parenthesis here, I don't have anything that's squared. So this is actually already factored. So I can kind of skip out on the factoring step and go straight to zero product property and set each part that contains a variable equal to 0. So I'm setting the GCF of x equal to 0 and x minus 7. So I get two solutions, x equals 0 and x equals 7. Okay, what about this guy, the one that has the oops? I have a big cloud there, which means that, I'm going to tell you something important, like a strategy that you should use and remember in the future when you see other problems that look like this. And what is different about this one that causes us to not want to factor it? It's the fraction. Do you see the fraction? We don't like it. How do we deal with those fractions? Remember, we clear the fraction by doing what? Remember, we got to multiply each term by the LCD over 1. So we want to keep that strategy in mind anytime we see a problem with fractions. So this one has a denominator of 4. This one's denominator is 1, 1, 1. So I'm going to multiply each term by 4 over 1. And going from there, that is going to leave me 4 times 3 is 12 divided by 4. Well, that'll be 3 because the 4s will cancel anyway. So I got 3x squared plus 4 times 8x, 32x, plus 20 times 4, 80, equals 0 times 4, 0. Okay. Now that we're at this point, it looks more like the other ones we've been doing. So we would go ahead and factor and solve like we have before. I'll spare you the details on that. So I'll put dot, dot, dot. That means I'm not going to actually solve it. That's just what we would do next. Which brings us to our second method of solving quadratic equations, which is the square root method. Now, the factoring method only works if we're able to factor. The square root method only works if there is a squared term and a constant term. Squared term and a constant term. There can be no linear term. Okay, so what is a squared term? A squared term is like 2x squared or 5x squared or x squared. A constant term is like a number, like 7, 12, negative 18. There can be no linear term like 2x, negative 3x, 8x. So in the square root method, you can only have a squared term like x plus 4 squared. There can be no linear term. So here we have a squared term and a linear term. So we have 3x minus 2 squared minus 64 equals 0. It looks a little bit weird because of the 3x minus 2 squared, and you certainly could like FOIL that out and then combine like terms and solve by factoring, but this is going to be the fastest way to solve a problem like this, even though you got to remember that you can do it, it is faster. So the first thing we're going to do is isolate the squared thing. So if we had like 2x squared, we would just want to isolate x squared. 5x squared, we would want just x squared. In 3x minus 2 squared, the 3x minus 2 squared is the squared thing. So we will need to get the 64 onto the other side, and we'll have 3x minus 2 squared equals 64. That is the squared thing isolated by itself. The second thing we're going to do is we are going to take the square root of both sides of that equation. When you do that, you need to remember to put the plus or minus and here's a hint, it goes on the constant. So when I take the square root of both sides, I'm going to end up with 3x minus 2 on the left side. And on the right side, if I put 8, if you put 8 like on a test, I'm going to write you a note, what did you forget? And you'll be like, I don't know. But every time I ask you, what did you forget? The answer is almost always the plus or minus. Because if I take 8 times 8, I get 64. But if I take negative 8 times negative 8, I also get 64. So we have got to remember the plus minus every time you take the square root of both sides. If the square root's already in the problem, you don't have to worry about it. But as soon as you draw that square root on both sides like that, you got to remember to do plus minus. Then the third thing we're going to do is that we still need to solve for x. Now there's 2 ways that you can do this. Method number 1, we can write 2 equations right from here, one with plus 8, one with minus 8. So we could go 3x minus 2 equals 8, 3x minus 2 equals negative 8. That's certainly one way to do it. The other way to do it would just be to add 2 to both sides and get 3x equals 2 plus or minus 8. And then we would do 3x equals 10, 3x equals negative 6. So either way, we're going to get the same answer. I tend to prefer to do mine this second way. So then I'll put like over 3 over 3. So I get x equals 2 plus or minus 8 divided by 3. Now we can't stop there. We actually have to go for all the way to the end and do 2 plus 8, which is 10 thirds, and do 2 minus 8, which is negative 6 thirds, which then simplifies to negative 2. So I would have these 2 answers, 10 thirds and negative 2. our third method for solving quadratic equations, completing the square. Unlike the first two methods, completing the square is going to work for any quadratic equation in the form ax squared plus bx plus c equals 0. So I will take you through completing the square one step at a time. We're going to write out the steps on here. Then we're going to solve this equation. Then we'll do one more example on the next page of completing the square. It's going to always be those same steps. Step 1. For step 1, you want to get everything that has variables on one side of the equation and your constant on the other side. So we will add 3. We get x squared minus 2x equals 3. Step 2. In step 2, we're going to divide each term by a. That's the coefficient of x squared. Now, in the problem that we're dealing with here, the coefficient of x squared is 1. So really, dividing each term by 1 isn't going to do anything. We'll still have x squared minus 2x equals 3. I'm leaving a space there. You'll see why in a minute. The third step, this one's the longest step, and I think possibly the most confusing. So what we're going to do is I'm going to write some words up here in a moment, but for now, I'm going to write this. We're going to find b divided by 2. Okay, what is b? B is this guy. In ax squared plus bx plus c equals 0. But it's whatever your new b is. So it's going to be negative 2 in this case. So we're going to divide b by 2. Then we're going to square it. And that's going to tell us the magic number that completes the square. And we are going to add it to both sides. Okay, I'm going to write some words up here in a second, but first let's do it. So we are going to take b, which is negative 2. We're going to divide it by 2, and we're going to square it. So I'm going to go negative 2 divided by 2 squared. Negative 2 divided by 2 is negative 1. And when I square it, I get positive 1. So I'm going to take this number here. 1 is the number that completes the square. I'm going to add it to both sides. So I'm going to put it here. I'm going to put it here. So I'm going to go plus 1 here, plus 1 here. So to kind of write that in words, we want to find b divided by 2, which sometimes is better to think of as b divided by 2 or 1/2 times b, because those are all the same things, but sometimes it works better in the problem. Then we're going to square it. Then we're going to add it to both sides. Okay, b divided by 2 squared, that's the number that completes the square. We added it to both sides. Then the next step we're going to do is we are going to factor. Now, the factoring step is actually like the easiest part of the whole entire thing. What you're going to do is you are going to literally take whatever your letter is, put it in a parenthesis, and then you're going to take this number that's inside here, drop it in with it, and put squared. Whatever that number was, that b divided by 2 number is going to go in there. So in my problem, my letter is x. So I'm going to go x, and then I'm going to take this number right here that's in the parentheses, -1 squared. And then I'm going to add these two numbers on the side and get equals 4. Then we are back to the steps that we just had, the square root method. This looks like the square root method again. So we are going to take the square root of both sides. We are going to remember the plus minus. And we are going to solve for the variable. So at this point, I'm ready to take the square root of both sides. The left side is going to give me x minus 1. The right side is going to give me 2. Just kidding. It's not 2. What is it really? Because it's not 2. Because what did I forget? The plus or minus. So x minus 1 equals plus or minus 2. And then to solve for x, I will add 1 to both sides. So I get x equals 1 plus or minus 2, which gives me 2 problems to do. 1 plus 2 gives me x equals 3. 1 minus 2 gives me x equals -1. That's the same answer that I would have gotten by factoring as well. But I could not have solved the original problem by square root method because it has that linear term. Okay, we're going to run those same steps on this problem. CTS is completing the square. So you'll notice that this one is going to have that second step that the other one really didn't because its coefficient is 2. So here we go. First step, get variables on one side, constant on the other. So step 1, move this guy over to there. 2x squared plus 5x equals 8. Second step, divide each term by the coefficient of x squared. So divide by 2, divide by 2, divide by 2. So we get x squared plus 5 halves x, remember to leave yourself a space now, equals 4. Now this one is slightly yuckier because it has a fraction. So when we go on to our next step, which is to find b divided by 2 or b over 2 or 1/2 times b, we have to deal with a fraction. So in this case, it's easier to do 1/2 times b. So 1/2 times 5 halves squared, which is 5/4 squared. When I square that, I get 25/16. Now this gives me like 2 pieces to the puzzle. This is the number that completes the square in case anyone ever asks you what's the number that completes the square. This is it. And then this is the number that I use for factoring. Okay. So I'm going to add this number that completes the square to both sides. And then on my next step, I'm going to factor. Remember, this is my factoring number. So I take my variable, which is x. Since this is positive 5/4, it's x plus 5/4 squared equals, now I do have to add 4 plus 25/16. So 4 over 1 plus 25/16. 4 over 1 would be the same as 64 sixteenths plus 25 sixteenths. When I add those together, I get 89 sixteenths. Then my next step is to take the square root of both sides. Square root. That gives me x plus 5/4 on the left equals. Now I want to think about square root of 89 sixteenths. I really want to think of it like it's two separate parts. So I can do the square root of 89 over the square root of 16, which 89 is prime, so it's going to stay like that, square root of 89. But 16 does have a root of 4. And then we got to remember always to do the plus or minus in front of it. So the square root of 89 over 4. And then we got to solve for x. So subtract 5/4, subtract 5/4. And we get x equals negative 5/4 plus or minus square root of 89/4. Now, we don't want to leave our answer looking this way because it's just slightly impolite. So what we'll want to do is write it as all one fraction. So we'll have negative 5 plus or minus square root of 89 all over 4. That's a perfect way to leave your answer for me. I think also my math lab has that plus or minus key, so you don't have to type all that stuff in. But also don't give me a decimal unless it says what to round to. So just leave it like that. Now this format, though, should look really familiar to you because it reminds us a lot of what we get with the quadratic formula, which happens to be the fourth method that we are going to talk about for solving quadratic equations. Quadratic formula. The quadratic formula works for every quadratic equation that is in standard form Standard form is ax squared plus bx plus c equals 0. Now, I hope you all remember the quadratic formula because in Algebra 2, we sang it. Mrs. Black sang it. Remember, it goes to Pop Goes the Weasel. It goes x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. Mrs. Black sings way better than I do. So one of a few things that I want you to keep in mind is that this right here is not negative. It means the opposite of b. So that if b is positive, it will be negative, but if b was negative, that would be positive. This b squared here, being as how it is a squared thing, it is always going to be positive. And when you are simplifying that b squared minus 4, you say, oh, wait, do you guys remember what that's called? Do you remember what it's called? It's called the discriminant. Discriminant. And that's going to tell us some cool stuff. In a minute, we'll come back and write some things about it. So leave this stuff blank over here. Okay, when you're working through the quadratic formula, after you substituted all your numbers into the quadratic formula, you're going to simplify what's inside the b squared minus 4ac. So let's just say when simplifying b squared minus 4ac, you want to look to see how many negatives you have in here. If you have like if A and C and -4, if those are all, if you have two negatives, you're going to be adding those two numbers. But if you have one or three negatives, you're going to be subtracting. So in these three spaces, you got -4, you got A, and you got C. If there are two negatives, you're going to add your numbers. If there are one or three negatives, you're going to subtract your numbers.
Mr. Lancaster and the council.
When you're done working through your quadratic formula, it might look something like this with numbers in all those spaces. If you have something in common, all three of these spaces, you have to simplify. So you're going to simplify if there is a common factor. Okay. More on this guy later. Let's work through one of these. So first of all, this dude is not in standard form. So we are going to need to clear those fractions. And remember, to clear the fractions, we want to multiply by the LCD over 1. So let's see what our LCD is. We've got x minus 3 as part of our LCD. We have x, that's part of our LCD. And then this guy just has a denominator of 1, so we don't have to worry about him too much. He's just going to take care of himself. So working through that, the x minus 3s are going to cancel. I'm going to have x times 2x, so 2x squared plus these x's are going to cancel. That's technically 1 times x minus 3. And then on the right side, nothing cancels. I just basically have 4 times x minus 3 times x, which by the distributive property, I can rewrite as 4x times x minus 3. Then moving forward with that, I'm going to distribute that 4x. I'm going to distribute the 1, which is kind of not very exciting because, yeah, it's like that. And then on the right side, 4x squared minus 12x. And then I want to get this thing in standard form, which means everything's going to be on one side of the equal sign with a 0 on the other side. It is really preferable that you start out with a positive leading coefficient. For that reason, I am going to move my 2x squared over to this side, which means I got to move everything over to this side. So my 0 is going to be on the left, but that's okay because the equal signs are two-way streets. But I'm going to have 0 equals 2x squared minus 13x plus 3. Then I can go ahead and use the quadratic formula. So in the quadratic formula, I need to know what a, b, and c are. A in this problem is 2, b is negative 13, c is 3. So as you write out your quadratic formula, here are going to be, like, I'll talk you through my biggest tips. We write x equals, that's the only place in the quadratic formula that a variable lives. All the rest of them are going to be numbers. So the opposite of b, since b was negative 13, that will be positive 13, plus or minus the square root of. Now, I don't write negative 13 squared. I literally just do 13 squared in my head, which is 169, or get a calculator. And then minus 4 times a times c. And then it's all divided by 2 times a. So I just do 2 times a and put 4. Now at this point, I just work through my discriminant kind of on the side over here, so I don't have to copy this down a bajillion times. And I'm going to have 169 there. And then if I cover up the 169, just do this multiplication problem. Negative 4 times 2 is 8, times 3 is negative 24. So you see what I was talking about with the negatives. There's one negative, and I'm going to be subtracting those two numbers. So that is going to give me 169 minus 24 is 145. That's in a radical, so I got to think about simplifying the radical. 145 is obviously divisible by 5, which would be 29. 5 and 29 don't break down anymore, so that square root of 145 can't be simplified. So I would have x equals 13 plus or minus the square root of 145 all over 4. That cannot be simplified any further. Remember that if it could be simplified, I would have to look at those three numbers to be able to divide out a common factor. I bet we have a couple more examples of this. Oh, indeed we do. Only one more example. Interesting. Okay. Square root of x squared. No, I can't read. X squared plus the square root of 2 times x minus 2 equals 0. And we are supposed to solve this using the quadratic formula and round to 2 decimal places. So we're going to have to use our calculators for this. This dude is already in standard form. So I can get my values for A. A is 1. B is square root of 2. That's weird. C is negative 2. So I'll have x equals the opposite of b, so negative square root of 2, plus or minus square root of b squared. Square root of 2 squared is a regular 2, minus 4 times a, which is 1, times c, which is negative 2, all over 2a. So 2 times 1, 2. Okay. Let's work through the little discriminants off to the side. 2, and then negative 4 times 1 times negative 2 is plus 8, which ends up being 10. 10 can't simplify as a radical because it's really just 2 times 5, so no pairs can come out. So I get x equals negative square root of 2 plus or minus square root of 10 all over 2. Don't be tempted to simplify anything here. This 2 that's outside of a radical cannot simplify with this 2 that's inside the radical, or this 10 that's inside a radical. You'd need to be looking for the numbers, the coefficients out in front of those radicals. So that can't simplify. What we do need to do, however, is get our graphing calculator, or your whatever you're using for your calculator, and type this in. The easiest thing to do is like the whole numerator and then hit enter and then divide by 2. So I will do negative square root of 2, and then I'll do the plus one first, plus square root of 10, and I want to get that answer, enter, and then divide by 2, enter. So one of my answers is going to be x is approximately, we're going to the nearest 2 decimal places, 0.87. And then your calculators can do this cool thing where you can go up and highlight that line and then hit enter. And then I can go over to the addition sign and change it to subtraction and hit enter again and then divide by 2. So the other value would be negative 2.2. I'm going to 2 decimal places. So look to the right, negative 2.29. Ooh, constructing a box. This little story problem here is in just about every math curriculum I've ever seen. We do them in Algebra 2, we do them in Algebra 3, we do them in college algebra, we do them in calculus. I haven't seen it in statistics. but you'll see it many more times, if you go further in math. So what we're doing is we're going to cut a square of 9 units. Like there's always different varieties. Sometimes we don't know how big we're cutting the square. This time we do. We're going to cut out squares that are 9 units, and then we're going to fold up the edges to form a box. And the box has to hold 144 cubic units, which is volume. What should the dimensions of the original paper be? So here's what I know. I am going to be cutting out squares. We're going to pretend those are squares from each corner. So I cut those off and basically just throw them away. So they're gone. And they are 9 units. Like it doesn't say if it's centimeters or inches or what it is. But each one is 9. And then I'm going to fold my corners up so that like the bottom of the box is going to be here. This is the bottom of the box when I'm done, which theoretically should be a square, but because I didn't draw my stuff accurately, it does not look like a square. We're going to pretend though. So this is the bottom of the box. And then these are the sides of the box that I fold up. You see what I mean? So that we have a length and a width of our box, but because it is a square, our length and the width are going to be the same. We'll get to that in a moment. So here's going to be the length of my box. I'll just randomly label. There will be my width. And then this 9 is going to be the height of my box. When I fold it up, this piece becomes the side of the box. So it's 9 units tall. Since they talked about cubic units in the problem, that's related to volume. Volume for a rectangular prism is length times width times height. But we just said that it is a square piece of paper. So length and width are going to be the same. So now my volume is width times height. And I know the height and I know the volume. So my volume was 144. The widths I don't know, so I'll go W times W is W squared, and the height is 9. So from here, I can just solve this equation. It's like square root method. So I want to isolate the squared thing by dividing both sides by 9. 144 divided by 9 is 36. So 36 equals W squared. And from there, we should take the square root of both sides. And we're going to remember to put plus or minus over there. So the width will be either positive 6 units or negative 6 units. But that does not make a lot of sense for it to be negative 6 units. So we're going to say the width is 6 units. That's the width of the box after we cut it. W. W width is 6. So this guy right here is 6 units. But they actually want to know what the original dimensions of the box are. So they want to know this length by this length. So we have to figure out that this section right here is 9 units. This section right here, oh, my drawing is real bad, is 6 units. And this section right here is 9 units. So this whole side originally was 24 units. And same thing down here. Here we have 9. Here we have 6. Here we have 9 again. So the original paper would have been 24 by 24 units, whatever those units are.